Hello everyone, welcome to my channel Hari PS videos. Thanks for my subscribers and thanks for my viewers for your encouragement and thanks for giving like and thanks for giving comment. But I did not receive many comments about my teaching and no likes, just watching that too. So whatever it is, thanks for my subscribers and thank you for watching my videos regularly. And once again I am requesting you, so please share my channel with your friends or the relatives who are studying class 10 in various schools. And I'm also requesting to you, my subscribers, the time is available, so please watch my videos and give a like, make a comment and encourage me. Then let us start our session with the topic soaps and detergents. Coming to the last topic of the chapter in carbon and its compounds. Carbon and its compounds. Then soaps and detergents. So we no need to introduction about the soaps and detergents because in our day-to-day life we are using them, but there is slight difference in between soaps and detergents. Let us know, right? If we wash our dirty hands with the water alone, they do not get clean. But if you use some soaps or detergents, powder, the cleaning becomes very easy. The cleaning becomes very easy. Then any substance as cleansing accent is called as a detergent. In other words, any substance which can remove dirt, is called as detergent. So the substance which can remove dirt is called a detergent. Right? So there are two types of detergents. One is soaps and detergents. Soaps and detergents. Or you can say that non-soap, soapy and non-soapy detergents. So in every language, soapy detergents are called as soaps. Soapy detergents are called soaps. Then another non-soapy detergents are called non-soapy detergents are called synthetic detergents are simply called detergents. Soapy detergents are non-synthetic, non-soapy detergents are called synthetic detergents or just detergents. So, in our daily life language, when you talk about a detergent, it means synthetic detergents, though the real sense of the word soap is a detergent or cleansing agent. The real meaning of soap, is detergent, or cleansing agent, or we can say that cleaning agent. Soaps and detergents both are used for washing clothes, cleaning our body, sanitation, shaving soaps, hair shampoos, cleaning utensils and textile manufacture. We will discuss soaps and detergents in detail. So this is about just introduction regarding to the soaps and detergents. Soaps and detergent. Let us discuss about soap and detergent, how they remove the dirt, what process happening in the process of cleaning or removing the dust from the clothes and from our body. Let us know about soaps. Let us discuss about soaps. Right. Let us know. A soap is a sodium salt or potassium salt of. A soap is a salt of sodium or potassium, containing or of a long chain carboxylic acid, long chain carboxylic acid, which has cleaning properties or cleansing properties in water. So a soap is a salt of sodium or potassium, of a long chain carboxylic acid, which has cleansing properties in water. A soap has a large non-ionic hydrocarbon group and ionic group. It has two parts. Soap has two parts. One is non-ionic hydrocarbons chain or long chain. The other one is ionic part. So as we know, hydrocarbons are covalent compounds, not ionic compounds, non-ionic or non-polar compounds. Examples of soaps are sodium slate, and palmate. Sodium stearate and other one is sodium palmitate. Sorry. Another one is sodium palmitate. These are the two kinds of soaps. Sodium stearate and sodium palmitate. So sodium stearate is it has its formula C17H35 COONA. It is C15H31 COONA. Sodium stearate form C17H35 COONA, C15H31 COONA. So this is obtained. Sodium stearate is obtained by the combination or by the reaction of sodium stearate soap is the sodium salt of long chain saturated fatty acid called stearic acid. So C17H35 COOH. C17H35 COOH is called as stearic acid. So C15H31 COOH is a palmitic acid or palmitate is palmitic acid. So when in place of hydrogen is displaced by sodium. Here also hydrogen is displaced by sodium. Then it is called as a sodium stearate. Then this is called as sodium palmitate. Nothing but simply you can say that the esters, right? Acetates, ester groups. You can call esters. So these are. So a soap is a salt of strong base like sodium hydroxide, and a weak acid means a carboxylic acid. So a solution of a soap in water. So because of generally this happened, right? This happened when sodium hydroxide is added to it. So by this combination we get C17H35 COOH plus water. Similarly, this is also happened when it is reacted combined with sodium hydroxide. It gives C15H31 COONA. So here sodium hydroxide is strong base. Here stearic acid or palmitic acid both are the weak acids. So as we discussed in acids, bases and the salt chapter, one strong base, one strong weak acid is combined together. It gives the basic salts. So soaps are the basic salts. Obtained by the strong alkali or base like sodium hydroxide is combined with weak acids like carboxylic acids. So soap solution is a base. So it turns. So turns red litmus to blue litmus. It changes red litmus into blue litmus because has a basic nature, because obtained by the strong base and by the weak acid. Strong base and weak acid then gives a substance, that is sodium citrate or sodium concentrate, or the sodium citrate or sodium concentrate can be called as a soap. So soap is basic in nature in water, so it turns red litmus into blue litmus. Red litmus into blue litmus. Right. How this soap is manufactured? So let us discuss the manufacturing of soap. The manufacturing of soap. And here soap has two parts ornamental. One is long non-ionic hydrocarbon chain. So C17H35, C17H35, C15H31, C17H35 and C15H31 are the non-ionic hydrocarbon chain. Non-ionic carbon chain. Then other one is the ionic group. Other one is the ionic group. So COO minus Na+, COO minus Na+, because this part is ionic part. Ionic part. This part because ions are formed. Here no ions are formed. That's why it is a non-ionic part. Ionic part. Ionic part. Non-ionic part. Right. Let us know manufacturing of soap. So soaps are nothing but obtained by the soap is made from animals' fat and vegetable oils. Animals' fat or vegetable oils. Fats and vegetable oils are naturally occurring esters of higher fatty acids or higher carboxylic acids. Long chain carboxylic acids are called as fatty acids. So these fatty acids contain naturally esters and an alcohol called glycerol. When fats and oils obtained from animals and plants are heated with sodium hydroxide solution, they split to form sodium salt of higher fatty acid called soap and glycerol. So when fatty acids obtained from plants and animals, they are heated with sodium hydroxide. These fats are vegetable oils as contain fatty acids. Fatty acids nothing but long chain carboxylic acids are heated with sodium hydroxide. So fatty acids obtained from animals and plants, nothing but vegetable oils, is heated with sodium hydroxide. It gives soaps and glycerol. Here soap is nothing but a kind of ester. Soaps are nothing but a kind of esters. So soap is obtained So if it is a fatty acid has a stearic acid, the stearic acid is combined with sodium hydroxide and gives sodium stearate. If it is a fatty acid containing palmitic acid, then react with sodium hydroxide and gives sodium palmitate. 8 stearate means, so for example C17 H35 COO Na. This part is called as a ester. This part is called as ester. So nothing but sodium soaps are nothing but sodium esters, means a kind of esters only. Sodium salt of higher fatty acid. Sodium salts of higher fatty acid nothing but esters. And glycerol is obtained. Glycerol is obtained. So here glycerol is one kind of alcohol. Alcohol is obtained. Its formula CH2 OH glycerol. So depending upon the fatty acid, depending upon the long chain carboxylic acid. In this way, we have to manufacture. We manufacture the soap. When fatty acids from animals and plants, oil from vegetable oil, fats from animals, heated in the presence of sodium hydroxide. So soap is obtained. Soap is obtained. What is soap? Soap is a salt of sodium or potassium of higher fatty acids, nothing but higher carboxylic acids. So after heating sodium hydroxide, when the fatty acids are reacted with sodium hydroxide by heating in soap and glycerol. So in this way we have to make our soaps. Even we can also make the soap and soaps in the laboratory of our school, of your school, and in home also. How do we prepare soap in the laboratory or in the home? For that, three required materials. They require three materials. One is vegetable oil, nothing but castor oil. Example: castor oil, cotton seed oil, linseed oil or soya bean oil. So cotton seed oil, soya bean oil, etc. Then sodium hydroxide. This is also called as a caustic soda. And sodium chloride, common salt, required common salt. For making a soap in the laboratory or in homes, we need to require three things. One is vegetable oil obtained from castor oil, cotton seed oil, soya bean oil, linseed oil, or whatever. Then sodium hydroxide, sodium hydroxide or caustic soda. Then other one is common salt, sodium chloride. Procedure. Soap can be prepared in the laboratory as follows. First one, take about 20 ml of castor oil. Take about 20 ml of castor oil. Required 20 ml of vegetable oil. In a beaker. We have taken 20 ml of vegetable oil. 20 ml of vegetable oil. Then add 20% of sodium hydroxide. Add 20% of sodium hydroxide. 20% of sodium hydroxide solution or caustic soda to this. After, so add 30 ml. Add 30 ml of 20% concentration of sodium hydroxide in it. Heat the mixture. So this is the mixture of 20 ml of vegetable oil, 30 ml of 20% of sodium hydroxide solution. Heat the mixture. Heat the mixture with constant stirring. Heat the mixture with constant stirring. Then, so until a soap is obtained, a paste of soap is obtained. Then add 5 to 10 grams of, then after heat constantly, stir, heat and stir, heat and stir, heat and stir. Heat and stir the mixture until a paste of soap is formed. Until a paste of soap is formed. Then after add 5 to 10 grams of sodium chloride, nothing but common salt. Nothing but common salt. Then stir the mixture well and allow to cool. Again stir the mixture. Again stir the mixture and cool. Stir the mixture and cool. On cooling the solution, solid soap is separated out. The solid soap is separated out. When the soap sets, it can be cut into pieces called soap bars. After soap formation, when we cut into small pieces, then we can call them soap bars. Soap bars. We can call them soap bars. So in this way, we have to make a soap in the laboratory or in our home. What are required? Vegetable oil, castor oil, cottonseed oil, soybean oil, whatever. Sodium hydroxide is common salt. In a beaker or in a container, we have to take 20 ml of vegetable oil. To this add 30 ml of 20% of sodium hydroxide solution. 20% of sodium hydroxide. The concentration of the base, the concentration of the sodium chloride is up to 20%. Mix them, heat and mix them. A paste of soap is obtained. Then add 5 to 10 grams of common salt and again mix it and cools down. After cooling, a bar of a soap is obtained. Then you can separate the soap and cut into small pieces. That pieces are called as soap bars. That pieces are called as soap bars. Right? Here, why should we use this common salt? Why we have to use common salt in the making of or manufacturing of soap? Because common salt is added to the mixture to make the soap come out of the solution. Though most of the soap separates out in its own, but some of it remains in solution. Some of it remains in solution. Common salt is added to precipitate out all the soap from the aqueous solution. So soap is formed in the solution, but some cases and most of the soaps are comes out from the solution. Still any is present in the solution. To remove the remaining part of the soap, in the solution, we have to add a common salt. Actually, when we add common salt to the solution, then the solubility of soap present in it decreases. The solubility is decreases, due to which all the soap is separated out from the solution in the form of a solid. If we did not add common salt in the mixture while making soap, so the soap is dissolves. The soap is mixed into the solution, dissolves in the solution. So to avoid such a problem, to decrease the solubility of soap in the aqueous solution or in the solution, salt particles are added. The salt particles are reduce the ability of dissolving soap in water or in a solution. So the dirty clothes and dirty body have usually oil or grease particles which hold dirt on clothes and skin respectively. The soap which is used for washing clothes or bathing works by making the oil and grease particles dissolves in water. Because we will discuss later. So why should we add salt under? To reduce the solubility of soaps in the solution, to separate out the soap from the solution. So while preparing these soaps, whenever we add some perfumes, then it will get different kinds of odor, different kinds of smell, right? So this is about the soap making. Then let us discuss how the soap is remove the dust or dirt, oil from the body and clothes.